and this is our fourth session in our series on designing online learning environments. And the purpose really of today is to talk about how you can move labs into a digital space. And that's a fun topic because typically people wonder, well, how can you do that? And there's a lot of controversy over, well, how do you take something that's physical and hands-on as a lab and put it in an online environment? And these two gentlemen are going to talk about that. So ideally, this will just be an hour of an open conversation. If you've attended one of these before, you probably know how it goes. We invite you to ask any questions that you may have, or if you'd like to challenge and push back, we're here for that as well. And if you just want to make general comments, that's great too. So today we really hope to kind of get this practical and tactical discussion going, as well as a theoretical discussion of how to move labs into a physical lab into an online space. So I'll do a quick introduction and then I'll give you maybe a few seconds to follow up. And then I'll kick us off with a few questions, and feel free to chime in if you have any questions as we go along. So both Dr. Rose on my left and Boucher and Dr. Powell work in the Produce program, and the Produce program is an online engineering program over at the engineering school. And I'll go ahead and let Ms. James kick us off and just tell us a little bit about who you are, what you do, anything else you want to add about Produce, and then Dr. Powell can follow up.
So I'll start by saying for better or for worse, and of course Harry and I think it's for better. We're both engineers in our education background and training. I did my graduate work here at the University of Virginia and stayed on in the engineering school. My background is in material science, but I do a lot of program administration, including administrative oversight of the online and distance learning programs in the engineering school. I sense a little bit from today's discussion is I think of myself as a little bit more the theoretician on this, and I would characterize Harry as a bit more the practitioner, but Harry's welcome to modify that characterization as we go along. But I'm interested in some back and forth dialogue and thinking a lot about this, trying to make some of these sort of things happen in recent years. And by no means are we at the finish line yet. Lots of opportunity for continuing to develop and think about these sort of online lab activities. Harry?
Okay, well, I graduated from here undergrad a few years ago. And for a number of years, we had a company that designed and manufactured automated sorting equipment. And I came back about 12 years ago or so and ultimately got a PhD and now I'm teaching in the Department of Electrical and Computer Engineering. So, and the courses that I teach, several of them do involve this remote learning concept.
So I thought one way to start, I'm not sure how, where everyone is coming from, so I think it was helpful to start if either of you, probably you, James, could just give us an overview of the types of labs that you have, just so that we can get a layout of the land.
If I could maybe just start with a little bit of historical background, not going too far back, but we talked about this program, Engineers Produced in Virginia, the Produce program for short. This started on the order of a half dozen years ago when a number of communities and companies, engineering firms in the state, approached the engineering school at UVA and said, you know, in our community, often rural communities in Virginia, we don't have sufficient access to engineering talent. We have individuals in our community who go away to Charlottesville, Blacksburg, or somewhere else for their studies, and then they don't come back. And we have companies here, we're doing engineering business, we could grow our business if we had greater access to talent. And so is there a way that you could work with us to educate these young people, not necessarily just young people, but also a little bit older adult learners in the community so that we might get our hooks into them early and keep them. And so what we developed was the idea that the students would start at their community college around Virginia, do their first 2 years of study with their local community college, and then apply, as usual, as a transfer student to UVA. And then if accepted, they would do 3rd and 4th year studies with us towards a bachelor's degree in engineering. And so that's the model that we kicked off in 2007, and in 2009, UVA started teaching courses as a part of this. Now, when we got started, the question is what of all, I mean, we offer 9 or 10 undergraduate degrees in engineering here on grounds. The question was, what part of that portfolio do we bring out? What we decided to do at the outset was to bring an interdisciplinary degree where instead of having, say, electrical computer engineering roll out their entire undergraduate degree in electrical engineering, we could work with the faculty there to offer a minor, a subset of classes in electrical engineering. And then we had the mechanical engineering department step up and similarly offer the courses towards a minor in mechanical. And material science offers a set of classes for the minor in material science. And students are able to put these together into the interdisciplinary Bachelor of Science degree in engineering science. And the idea there was, well, each department's putting a little bit into the pot, helping to get this up and running. And then as the program grows, we'll look at advancing, making other degrees available. Of the three, well actually all three disciplines, mechanical, electrical, and materials, have laboratory activities as part of their undergraduate education. At the moment, within our distance produced program, we're only offering distance lab activities in electrical engineering and mechanical engineering. Material science has one lab activity and they've just decided not to offer that particular class as part of the curriculum. And so if we think about exactly what courses are offered right now, we actually have 3 electrical engineering classes that have labs at a distance. There's actually a 4th one where we have them still come on grounds. And then we have 2 mechanical engineering classes that are done as labs at a distance. So, and Harry can certainly talk a lot more about the electrical labs, but just briefly, we have an introduction to circuit analysis, something called Electronics 1, and a digital logic design. Those are the 3 electrical courses. That 3rd one is actually computer science electrical class. And then in mechanical engineering, we have an introduction to mechanical engineering and a course called mechatronics. And so at the moment, that's our portfolio of 5 lab classes at the distance. Maybe that's enough of the first introduction. Let me stop there.
Can you tell us a little bit about what models and media examples you looked at as you started to move online? So moving a lab into an online space is pretty innovative, and not too many people are doing it or want to do it. There's a lot of resistance around it, particularly in the sciences. So where did you all look and what were you thinking about?
What I might do is let me put a couple headers, and I think I turned to Harry and asked for some of his comments as a little bit more of a practitioner. When we all started thinking about labs at a distance, we could do something that's purely computer simulation. So instead of building a physical electronic circuit, we just have the students work on a computer screen, maybe pull graphical elements together and wire it up. So you could do simulation. One of the models we've been exploring is what I call the personal equipment model, where you can get electronic components that are sufficiently inexpensive and small that you can equip the individual students at the distance with their own kit. Another one which Harry has thought of but we haven't implemented is actually using the internet to have students interface from a distance to equipment that's back here on grounds. And then of course we have the bit that we can draw these students from all across the state and bring them on grounds. And Harry, maybe this is a good point for you to jump in and your thoughts about plus and minus of a simulation versus the personal lab kit versus the remote access, because I know you've thought about some of that.
Yeah. So from what I have experienced with the students, I think that something that's totally simulation doesn't leave that experience there. There's clearly a missing element. And if I have a student that is transitioned from a course in which they did nothing but simulated sort of experiments, they have a really tough time dealing with reality. And the reality of actually putting together something, connecting the wires up and making it work is a lot more intricate than what you can do in simulation. And they suffer from that. And ultimately, engineering is about reality in the end. So I don't know that I have developed a warm and fuzzy feeling just yet for a remote lab that would be just done entirely in simulation. Okay. The other model is to have duplicated setups, close to duplicated setups for a remote student as the on-ground student in terms of lab equipment. And we are starting to move in that direction in electrical engineering. So by a year from now, most of what we do in terms of the actual physical hands-on laboratory experiment will be on equipment that is very, very similar in both our on-grounds lab as well as our off-grounds lab. Not exactly the same, but very, very close. And there are a lot of things happening with some of our suppliers that's making that start to approach a viable reality. And I kind of think if we're going to have remote students, that might be some sort of an optimal situation. The limit, yes, go ahead.
So, are those remote labs, are they in the community colleges? Or are they just a personal per student?
At their home.
Yeah, and it's actually a good point. You could do either. And I could comment after Harry's done the moment about mechanical engineering, because we're not implementing, but we're thinking about additional mechanical classes in the future and how we might do them. And so there is the personal, but you could also do regional sites. Mm-hmm. Sorry.
Okay. The other model that is in the thinking stages right now is remote access to real equipment. Okay. And that is actually not a bad model for some things, because much of what's done, say for example in the power industry, is done remotely. So our local utility can remotely tell which transformers are up and which transformers are down, that sort of thing. So it's not a bad way to think. And we've been floating some proposals out there for actually building a remotely controlled power lab that would have all of the same equipment, but the students would operate it through sort of a remote data acquisition sort of setup. That's very much in the thinking and planning stages right now. It's not reality just yet. The other course that James alluded to was basically our power course. And the laboratory experiments there do involve lethal currents and voltages and things that can hurt you really bad. So for those students that are in that course, what we have gone to is a model in which they do all of their lab work in 3 to 4 sessions on ground. So they come up about once a month and complete all of their lab work for that length of time in a day. And that way they can operate the equipment the same way the on-ground students do. And at the same time, they can be relatively safe. Some of this stuff would be totally impractical to set up in an individual basis. So it might accidentally fit in this regional model at some point. I don't know. That remains to be seen. For the students that are doing their labs at home, for example, the course I'm teaching now that is electronics, and that's one that they do have their own equipment at home. And one of my goals for the coming year, this is the first time I've done this course myself, but one of my goals for the coming year is to have that home experience, equipment-wise, be much, much closer to the on-grounds experience. Well, the portion that's still missing on the home experience just yet, that we're dealing with, I suppose, mentally at least, is this notion of working on a project team. Okay, so the weekly experiments work, the teams are 2 to 4 people per experiment, per lab bench. And right now, as it stands, the people that are doing those same experiments remotely are pretty much working by themselves. And we have remote video set up so we can sort of see what they're doing, but the two-way communication right there, that's a link that I think we need to attack just yet, because that's probably the weak link in the area.
One of the kind of general question, are all your courses in the Produce program taught synchronously with the on-grounds course? Or are there any courses that are taught in Produce that are not at the same time being taught on-grounds?
Not in Produce. In our graduate program, CGEP, we have some asynchronous course materials, but at the undergraduate level, today we do everything in a synchronous manner. Now I say that, but actually one of the labs, and maybe this is Harry's talked a bit about electrical. The other gentleman who couldn't be here today is Gavin Garner, who oversees the mechatronics class in mechanical. He's gone about the lab development a little bit differently. So first of all, it uses a personal setup, just like the electrical engineering. So the students are equipped with materials of a couple $100, and they're able to put together small components that he has assembled, brought together for them. But what they do is he's written out a lab manual, and the students follow along the lab manual on their own during the week. He gives them access to teaching assistant office hours, so if they have questions at a designated time, they can get on the line. And then the mechatronics is the control of some mechanical physical system with electrical power, computer interface control. And what he has them do is use a webcam and video recording software to demonstrate the function of their setup at the end. So he says, okay, you're supposed to wire this up, it's supposed to be able to do X, and at the end, turn on your camera, demonstrate it to me, and then he has them upload the videos at the end demonstrating the function of their equipment. So that's a little bit of yet a different model. So kind of asynchronous, but you still have the teaching assistant time available for synchronous interactions.
So just listen, I'm starting to hear some of the specific technologies that you're using, like a webcam. Are there any other technologies or any other kind of like indispensable things that have really helped you all with your online lab, the different approaches?
I mean, the way I look at it is there's two things that we have to attack. Generally, I think there are two things we have to attack when working on these online distributed labs. And one is the communications technology that we use for the audio, video, whether it's just a teaching assistant session or whether it's an actual extended lab session where maybe Harry needs to be able to see what the student is doing. So there's that portion of the technology, and then there is, for the actual academic work that they're doing, what is the equipment that's there. And Harry may want to comment a little bit on the tools that are there. I mean, one thing that comes to mind, Harry, is we have looked at equipment from National Instruments a fair bit. And you know a good bit more than I do, but they're a company that makes something called LabVIEW, which is a pretty well-known software package. They make quite a number of personal or small teaching equipment items. I don't want to say it's the perfect solution, but I think they have some intriguing materials in this area. Maybe you want to comment just a little more on that.
Well, yeah, and their equipment is, they make one set of equipment that's entirely useful and suitable for on-grounds laboratories that is several $1,000s per lab bench. And another much smaller, let's call it the little cousin of our setup, that accomplishes much of what the big one does, but it's also only a couple of $100s. The thing that attracts me to that is, from a software standpoint, from an operator standpoint, we can make it look the same, very, very similar to the on-ground students, to the off-ground students. It also gives us at least an opportunity to perhaps remotely operate the students' experiment as well at their site from on grounds to get more insight into what's going wrong or not. So I'm kind of attracted to that. It's also something that National Instruments is extremely interested in supporting.
But y'all aren't using that yet?
Well, this is, I think, is in active exploration.
Yeah.
We've looked at National Instruments solutions over time. We've actually piloted some of their earlier, the MIDAC technology earlier, weren't quite satisfied with its status a couple of years ago. But one of the things that is nice is National Instruments is a big company. They're invested in this area. So rather than us having to do everything homegrown, as you all can appreciate, I mean, they're marching it forward for us. Just to extend on Harry's comment, I think this bit of, for us, matching what goes on grounds and what goes on at a distance is important. Now, one, you could say, you know, it's all about learning outcomes, but we do have some other design constraints or objectives in terms of trying to educate these students in their home community. We don't have that here. But we have only so many faculty members and so many teaching assistants able to support the students, whether they're on grounds or at a distance. And getting into a little bit of education thinking, if we think about the cognitive load for the faculty member and for the teaching assistant, if your on-grounds equipment and your equipment for the students at a distance, if those systems are too different, then one, its design of experiments are challenging, but two, if you're the faculty member who is in a room with on-ground students and simultaneously you're trying to talk to the students at a distance and you're trying to think of, you know, what do they have at a distance as opposed to what's here? It's the same problem for the teaching assistant. I think that's part of what you're driving at is if we can get the look, feel, and operation of the on-ground system to come pretty darn close to matching what's at a distance, it just makes it easier for the design of the experiment, for the support of activities there. So I think that's something that in terms of what are we learning. Now in terms of the technology for communication and collaboration, which is the other side, I think in a number of ways we do have a pretty good idea of how to do that. I mean, we actually use, I like the Microsoft Link software for when we have a lab activity going on. It has very good, robust audio. The one thing, and I think Harry could comment a little bit on this, we use high-definition webcams, although you may not actually always get high-definition video when you're using it. But Microsoft Link is coming along there. But still, even with the high-definition webcam, sometimes I think you're getting a little bit of a restricted view, and there's even just, I think, training of the distance students about how to position it properly. So Harry's not looking at a circuit at some crazy angle. So
yeah, I mean, that's one of the things I've noticed. I've spent some time actually myself working with the students remotely, and that's the video side of the whole thing is clearly a limitation. When you have a whole experiment in front of you on a bench, you're looking at this and maybe you're modifying some stuff on the actual circuitry, but at the same time you're watching what happens out of the corner of your eye on the video, on the instruments. And that's a tough thing to handle video-wise. And I think we'll get there, but it's not quite there yet. It's the toughest nut to crack that I've had so far.
And I would say it's two things. One is the technology itself, say the software. And in some ways I think the software is real close because you can do a sharing of the desktop and you can transmit video. It's also an experience. How experienced are all of us? The faculty, the teaching assistants, our digital support assistants, our distance students in using it. Because it's one thing that the technology is capable of showing you the circuit, showing you what's happening on their computer screen, but if we're not all savvy users of this, it all of a sudden breaks down as opposed to the physical lab where Harry's actually looking over your shoulder. You know, if the distance student doesn't quite know how to present to Harry everything he needs to see.
And so does using some of this equipment or technology require that a standard set of like computers, for example, or operating systems and so forth?
We are, as a program, we're fairly specific about what platform the students need. I mean, broadly,
so you do have to think about this.
Yeah, so broadly we're on the PC as opposed to the Mac side. You can think of it needs to be a fairly modern computer. And one thing I will look at in terms of these new tablets that are emerging, you've got to be careful about how many USB ports you have on these. Because often these National Instruments and other solutions interface to the lab with software that's running on the computer. And they'll run that interface most often through a USB port. So if I think about something like the new Microsoft Surface Pro that has only a single USB port, may be okay, but I start to get a little nervous from the computer technology. Another thing for us is emphasizing to the students that it's best if they're running on a hardwired connection as opposed to wireless when they're doing this transmission, because if they get degradation in their wireless signal, that can lead to a drop in video quality, which all of a sudden now makes it more difficult. Yeah, things like that. So we're still gaining experience, but we do try to specify at the outset what the students need.
Does Internet 2 come into play for you guys in this at all? No, not an option? Or just
I don't
not?
think it's...
I guess that's true. Yeah.
That's one of the comments I have heard from the students. I mean, it's kind of a double-edged sword because we would like to be able to provide this experience for students in remote areas.
Right.
But remote areas frequently don't have very good internet service.
That's right.
So.
That's a challenge. So hence, the regional option might be
So I can
more
comment.
interesting.
Well, and I think that's it. I mean, I think we're still evolving.
Yeah.
We've tried some things, and I'm not convinced we're ready to give up on them.
Yeah.
Because there are some advantages, but in the end, you also have to make sure you deliver the learning outcomes. The other thing about regional centers that's interesting is there could be instances where, from a cost, a safety, or a size perspective, it just doesn't make sense to give the students their personal equipment. Mm-hmm. And yet, particularly some of the students we work with are in Southwest Virginia, and as part of the university's initiatives in Southwest Virginia. I mean, it is a 5-hour drive one way for some of these people to get here. So, if we think as engineers and designers, we have certain constraints. And so a regional center where we say, okay, you need to drive an hour, but then we can give you maybe better internet, maybe better video, and we can get you to some equipment.
And tech support possibly on site.
Could be, yeah, exactly, something like that. I'm not opposed to that, and I think students could work with that. Now, with that said, I mean, if you look nationally at some of the discussion about remote labs and giving students personal lab systems, why would you want to do this? And there are some educational motivations for giving students their own equipment. And one of those is that if you give students their own equipment, they have it 24 hours a day, 7 days a week. And in my mind, this is a distinct potential advantage compared to what we do in on-grounds, where students come in for 2 hours when the door is unlocked, and then 2 hours later we kick them out. Now, of course, some of our students won't take advantage of the extended length of time, but a student who sincerely wants to understand, but just needs a little more time to tinker and reflect. I mean, it's neat to empower the student for that thinking. The other thing is, and I think this is also, and gets me kind of excited to think about, is you can think about a student who's, really motivated in electrical engineering. Now they've got their own equipment. Yes, they have your assignment to do, but now they've got their equipment and they can start saying, I wonder if I could do this and that, and they start experimenting on their own. Now, again, for many students, they may never take the time or be motivated, but you could have some really exceptional students in the system. And if you empower them with the personal solution, all of a sudden you're not defining a ceiling for those people. They can take off. So, as I said, in some cases, from safety and expense or the dimensions of the lab equipment, the idea of personal empowerment, at least right now, may not be practical. But I like some of these personal empowerment ideas, and so that's part of the reason I'm trying to push us as a school to say, can we make this work?
So you fund that central, or you fund the equipment that you
Or do
give
the
out?
students have
Or
to-
does the students-
Right, so it's a bit of a mixed bag, both for students on grounds and at a distance. They may be asked to buy the little circuitry bits. In terms of our platforms at a distance, right now we are purchasing those, and the reason we're purchasing them is because we haven't settled on our solution. We're still in pilot experimentation, and so I'm worried if we have a student that's with us, say, 3 years as a part-time student, I don't want them to invest in a system in year 1, we change it in year 2, and they've had to spend money twice. And this is based on my experience back in college where I was taking 2-semester physics class. They changed the physics book between semesters, and I had to buy 2 physics books. And I'll tell you, 25 some years later, it sticks in my mind. And it's a little bit that same bit with the student. I don't want to put them through that sort of expense. Now later on, if we get to where we're really settled, let's say on this National Instruments parallel system, perhaps that is part of the investment that the student has to make. But right now, we're providing these kits.
Is it a loan?
It is
So
a
they
loan.
give it back. They give it back.
Yeah, and we actually give it in a, I go down to Kmart and we get a nice red toolbox, red and black toolbox, and everything fits in there, and we basically check it out.
Good.
And then they are expected to bring it back with normal wear and tear
Yeah.
expectations.
That's great.
Yes.
I had some questions. Harry, you introduced Harry, you mentioned Harry, you're exploring the remote, perhaps. Is it with Haptic Technology where surgeons are now doing surgery or distance? The same kind of technology where I'm moving this wire and I've got my hands in some gloves and they're telling me that I'm touching the computer. Am I making sense? So I'm looking
not,
through a video,
I think,
I'm looking through a video and I see all the components in front of me and I've got my hands in gloves and I'm moving the pieces around. Are you exploring anything like that? How's the remote or telesurgery field relate to the work that you're doing?
perhaps tangentially. Okay, and like I say, this whole concept is in the exploratory stages at the moment. But the haptics is not part of the current concept. Okay, the notion is more in what you would have to do to monitor and control, say, a scaled but relatively complete, say, generating station or transformer station, substation, that kind of thing. And a lot of that is I think there's a good model for doing that sort of thing remotely because much of it's being done in industry that way already. So they don't actually physically, have a robotic arm at a substation, we'll say, for interchanging transformers and that sort of thing. But they might very well test the transformers and monitor their performance. And these are the kind of components for which modeling is okay, but it's not, the simulated model is not nearly as effective at duplicating reality as reality is at duplicating reality. So the goal is more control of the equipment rather than haptic kinds of things that you might do with a surgeon.
It's interesting, I extend a little bit though on the thinking. We have a faculty member in mechanical engineering, and apparently he's in one of his classes that he's tried as part of this program. He often brings in gear systems, gearboxes, and clutch systems, and he wants the students in class to be able to touch and feel the resistance, the motion of the gears. And we haven't done it, but he's articulated the sort of desire or interest where, gee, if we had that glove box, haptics, touch the virtual gears, feel it resist. would be very pleased if we could do that, but we haven't explored that yet. We'd be happy if anybody wants to help us develop that. Go in that one. Yes. Yes.
The National Science Foundation has small business innovation research grants, about $225,000 to do in partnership with a small business, and it's the pilot. Revolutionary concept in education, not evolutionary. Then they do $750 million to take it to stage 2. So it might be something that every 6 months. And so June 13th, the due date.
Are there any other questions?
Questions from you?
Yes, questions for me. Just wanted to make sure everybody had a chance to ask. So you all have done a really good job at talking about some of the design considerations that you had to think about, the technology part, and then just how do you adapt something that's typically and traditionally on grounds to a virtual space. So I'm wondering, to kind of continue on that thinking, how have you been able to integrate this initially with departments and with faculty and students, because there's always that people aspect, and labs occur in a larger curriculum. So could you speak to how you all rolled out the idea of labs? How was it maybe received initially, and then how, I'm a student, how do you work with students so that they can market the online labs as an equivalent experience and part of their program?
I think this has been one of our greatest challenges, is that it's always about the people, right? Getting it integrated. And I'm not sure yet that we've done a great job of that. I think some of what Harry's talking about now in electrical engineering, looking at, say, National Instruments equipment, trying to develop a real parallel. What we did a few years ago when we got started with the PRODUCE program in, say, the 2007 to 2009 timeframe, we had grant money. We supported development of a distance online lab solution for some of these electrical classes. And what we didn't do well enough at the time was work on the overall department buy-in to the model that one of their own faculty members had developed. So it wasn't that we brought in a solution from outside, but rather we worked with a faculty member in the department. They developed a solution. But what happens with a number of these classes is faculty member number one teaches that class for 2 or 3 years. Then it gets transitioned over to the next person, and then a couple years later to another person. So you're all fine and dandy as long as that first faculty member, who's developed the solution, says, hey, this is great, I think this is what our students need to be doing. But if the next person who comes online to teach that class says, no, that setup doesn't do what I need, that's a problem. And it's more of a problem than in the physical labs that we've had here. Because traditionally, and Harry, you should jump in here in a moment, traditionally the physical labs that we have here are equipped with oscilloscopes, function generators, power sources, and supplies that are capable of quite a broad range of set points. And the equipment that we've given to our distance students does, at least today by necessity, function in a smaller operational space. So in the past, when on grounds you went from faculty member A to B to C, it wasn't that big a deal if the lab expectations changed, because the equipment on grounds in lab could do what the different faculty wanted. But that's not necessarily true. So we've stumbled on that, where I think, as I reflect back, yes, we invested, yes, we got faculty in the department engaged, but we didn't have the broader department discussion and say, as a group, is this proposal or is this now implemented design? Is this something we're all prepared to sign off on? So that's been a challenge. I don't know if Harry has any comments.
And the challenge is that what is on a traditional lab bench setup in one of our labs might cost, say, $10,000, $12,000 for all the equipment that's sitting there right in front of the students, and is capable of quite high performance. So what we're trying to do is to figure out what is the subset of that performance that we actually need. And I have a humorous expression, kind of like a TV game show or something. I say, okay, that I think for undergraduates, anything they need to learn, they can learn in 20 kilohertz or less. And that all of the principles can be taught without needing extreme performance from the equipment. So what we're trying to do is to come up with something that for a few $100s can duplicate the subset of performance that we have available in, say, a $10,000 lab bench setup. And that's been a challenge because different faculty members have a different concept of what subset that really should be. Okay.
I think broadly though, if you look, I mean, the discussions nationally right now about the cost of higher education, I think in a sense, pushing the envelope for online education is actually good for an institution like UVA. If we can push a department like electrical and computer engineering to say, okay, instead of $10,000, can we get this done for $3,000 on grounds? At the end of the day, that's good, because that means that for these lab setups where we may have, what, 8, 10, 12 of these setups in a physical lab, okay, instead of spending $120,000, now the department can spend $25,000 or $30,000. I mean, that makes a difference in terms of, you know, the cost of higher education. But you know, we're all busy, and so getting everyone together to have these discussions and come to agreement is the you know, faculty herding of cats, or I've heard was it moving frogs in a wheelbarrow sort of thing. It's a challenge, but that doesn't mean we shouldn't continue to work on it. I think, in my mind, it also has potential advantages. So, in mechanical engineering, where Gavin Garner has developed this mechatronics lab, where the students work asynchronously, meet with the TA periodically, and have their own equipment, he's invested tremendous time, effort, and thought into developing that solution. He's now thinking about adopting that solution with the on-ground students. So the spark was the online distance student, and it motivated him thinking of a new way of accomplishing the learning activities. And now he says we have it. We're almost at the point where he's ready to seriously think about giving it to some, maybe initially a pilot group, and over time implement it across the board for on-ground students. And I think this is important because one, it could be cost savings, as we discussed. The other thing has to do with the mobility issue. As you start to give these personal solutions to students, even our own on-ground students can become more mobile. Maybe they want to do a study abroad in a given semester, but they know they need that class in order to stay on track for graduation. Well, now, if we've got a solution that they can port wherever, and it doesn't have to be a study abroad. In engineering, it could be they're in a co-op or internship with a company, and now they want to take that one class to just stay on track. So as we drive towards these less expensive mobile solutions, I think it also, it's pushing us. Maybe it's pushing us out of our comfort zone, but I think there are potential advantages to be realized by the on-grounds program as well.
One thing that I keep hearing as the two of you talk is this added value of having an online lab, that it can transfer to the on-ground situation. And I'm wondering, how do you communicate that to students and their families? I don't know if you find it so much with the online students because they've elected to enroll in a program like Produce, but...
So I think it almost, in my experience, it almost comes down to the individual student. And because people can look at the exact same experience and interpret it in totally different ways. So one of the things about being a distant student, and it's true in this online lab activity realm as well, I think you have to be more self-reliant. And at the end of the day, I think some of that can prepare you to be a better engineer, a better working professional. That you didn't have the immediate crutch of Harry Powell being able to look over your shoulder, the teaching assistant right there to hold your hand at every moment. You had to figure it out yourself. And some students realize that. Others complain about that. So I think you can look at it either way. Now, it doesn't mean we should just cut them loose and say good luck, because I think we have a responsibility to support them up to a point. But there's also nothing wrong with putting students in a position where you don't have your 3 or 4 buddies to immediately rely upon. You don't have the TA immediately available. You don't have the faculty member. You're going to have to think. You're going to have to figure it out, because someday in a working environment, your boss is going to say, I'm giving you this project. I want you to deliver, not John down the hall or Joanne around the corner in the next cubicle. So, but as I said, different students will say, you know, this makes this a bad solution. You know, I didn't have the immediate help. Others say, man, that was tough. You know, like eating your Wheaties or your vegetables. At the end of the day, it's good for you. Harry, I don't know if you have any additional thoughts.
It's kind of a related thought, because quite a few of the courses that I teach have a team-related component, whether it's the lab activities or major design experience or something like that. There's team-related activity. And, you know, we have a big emphasis on that and all of that, and that's very, very good. But the dark side of that is that in nearly every team-based activity, there's the leader, and then there's 1 or 2 that are totally willing and totally happy with just glomming on to the results of their teammates. And I mean, I try to take steps to ameliorate that situation somewhat, but nevertheless it exists. And that's one thing for sure, is that the Purdue students don't have quite the same opportunity to glom on to somebody else's work. So.
And some of them complain about that.
That fits into the stuff that people are seeing with MOOCs, is that people can sign up, but the attrition rate is like 90%. If you give people responsibility, most of them aren't going to take that responsibility.
Exactly.
So then the question is, do you prepare people ahead of time to know that, you know, maybe there's a screening test to see whether they have what it takes to stick with something? Because otherwise they're probably going to drop out when they don't have hand-holding. But those who are successful are going to be more successful because they've had to learn how to do stuff on their own.
Yeah, I think there's the making students understand what they're getting themselves into. But I also believe that from an infrastructure development perspective, we do want to make sure that our distance students don't feel isolated. I mean, it's one thing to develop self-reliance and independence, but we need to be looking at the technologies, hardware, software, so that, you know, when appropriate, they do have robust connections to the faculty, to the teaching assistants, and to one another. And we need to make sure those students are comfortable in using it. So broadly, one of the things we do with our program is that distance students will come and spend 2 days here on grounds at the start of their program. One, they'll be learning about the different technologies, the communication collaboration technology. If they're going to go into these lab classes, they get the equipment and start to get an introduction. But also we try to get a meeting. I mean, okay, you're all here on grounds for 2 days. Meet each other a little bit, so when you see that person's in your class and you can see that they're online now, you know a little bit who it is and you can reach out to them. And even like on grounds, I mean, some of our students desire that more than others, but for some of them, if we take those steps early on and help build a student community, and Erica's the one who should answer questions on that, I think that does ultimately make a difference for them. And so, but it's, as Harry said, this bit of teamwork in engineering is critically important, but we shouldn't suggest that what goes on in teamwork here on grounds is somehow perfect, and we've got all these problems at a distance. There are challenges in both environments.
Can you talk a bit more about what you have in place for the community building between the distance students, and then does that interface at all? Do they have an opportunity at all to interface with the on-grounds?
So the first thing to keep in mind is that sure.
Sorry, guys.
No worries.
And I've got a bus date in about 5 minutes myself.
Sure.
The first thing to keep in mind is our courses are done in a synchronous live environment, and we always teach these classes at the same time to the on-grounds and to the distance students. So there's the opportunity for mixing. And Harry could comment on this a little bit. In some of the team activities, not necessarily lab activities, but for certain team design activities, faculty members like Harry will deliberately set up a team and say, you two on-ground students are going to connect with this off-ground students, and I want the 3 of you to do design work together. And that helps a lot, because what I see is if we just leave it to the students, a lot of our on-ground students today say, if I can just rub shoulders with these people who are on-grounds here and form kind of a buddy system, why do I need to go to the extra effort of connecting with that student who I've never physically met that's in Lynchburg or Abington or elsewhere? And so what our distance students see today is that often, not always, but often the on-ground students, unless they're particularly motivated by a specific professor and a specific activity, the on-ground students generally don't engage with the students at the distance. Some of the off-ground students, that's fine, but many of them, I think, would appreciate and value greater interaction. So some of the things we do to bring the students who are at a distance together, we use technology such that when they enroll in the class, they can see the names of everyone that's in their class, and the software that we use allows them to see when those students are online. So if we brought them together for a couple days at the start, and they start to know the names of one another, now they're in a class together, they recognize the names, they can see when those people are online, they can instant message chat, they can have an audio connection, they can go to a video connection, they can do desktop sharing together. And some of them use that. So what some of them will do just for regular study, they're working on a homework assignment where the professor has said, sure, you're welcome to sit down, I don't want you copying it, but you're welcome to collaborate on homework. What some of the distance students will do in the evening is they'll be at their desk, their colleagues somewhere else in the state will be at their desk, they'll open up this live connection, and sometimes it may just be an audio connection, and just as needed, they're talking back and forth. Our distance students are supposed to have a tablet, digital inking technology. So in theory, they could be working on a homework assignment and actually share it in real time with one another. Some of them do that. But I think a lot of times, as much as anything for them, it's they're working on a problem at the same time, and they've got an audio link, and they can talk to one another. And absolutely, some of them do that sort of connection.
Okay. So in my course in energy conversion, one of the things that I do is at the end of the semester, they have a team-oriented research project in which they present a tutorial on a subject to the class in the final exam period time on a topic that we didn't have time to cover during the normal work in the semester. And so for those teams, I have off-ground students participate. So each team will have a mixture of on-ground students and off-ground students. And I still have the off-ground students come in for the exam time to do their actual presentation, but the collaboration and that sort of thing takes place during the last few weeks of the semester between the on-grounds and off-grounds. And I try to make sure that I have a mix of the off-ground students on as many teams as possible.
For me, one of the things, when I look at this, the technology for the distributed collaboration, the technology is largely there today to do a tremendous variety of distributed collaboration activities. The challenge is, for most all of us, is we don't have experience in using the tools for effective communication and collaboration. And so, I don't know where you're supposed to pick these skills up necessarily, but in my mind, it's as much a comfort and an experience amongst the group of us in maybe having the right hardware and software, and then having experience in using it. And the one maybe example that we could all visually identify with is you get into something like a Skype call with someone, and maybe they turn on video. It even has to do with how do you present yourself, in terms of like a professional presentation. I don't know how many times it's the webcam that's embedded in the computer, and what I'm seeing is the ceiling tiles, and maybe the person I'm talking to is down in the bottom left corner, and not only am I seeing the ceiling tiles, but there's a ceiling fan or something else going on. I mean, we know when we go to a meeting and we make a presentation physically a bit how we're supposed to present ourselves. I'm not convinced maybe that we know how to present ourselves online, and that is just one small example of our comfort and experience in using online communication and collaboration tools. We're not great at it. I'm not convinced programmatically that we're great at helping our students off grounds, our students on grounds, our faculty. I mean, little by little we need to bring everybody up to speed. But I mean, you work in a global environment, and these sort of distance distributed collaborations are going to only become more important. And if we can help UVA students, all of them, become better at presenting themselves, and that's going to be part of their professional success later on. So I don't know if they need a seminar course in online interactions or something. But so we have a number of tools, and then we're doing some other things. Erica has been very valuable in helping us look about how do we build a sense of community. More broadly in terms of online education, online community, because you don't come on grounds just to take courses and just to sit in lecture halls. So much of the value of what goes on here on grounds is also the other interactions. And while we're not going to try to photocopy those into the online environment, we are thinking quite a bit about how do we create a sense of community where I'm not an isolated learner, and that I have opportunities to connect with others in ways that add to my intellectual development.
On that note, I think we have to end. It's about 1:40, so thank you everyone for coming out.